Artificial intelligence, or AI, is rapidly transforming our world. From self-driving cars to virtual assistants, AI is poised to revolutionize countless industries. At its core, AI aims to create machines that can perform tasks that typically require human intelligence. This includes understanding and responding to natural language, recognizing objects and faces in images, and making decisions based on data analysis. Two key branches of AI are natural language processing, or NLP, and computer vision. NLP focuses on enabling computers to understand, interpret, and generate human language. Computer vision, on the other hand, empowers machines to see and interpret images and videos. These fields are crucial because they bridge the gap between humans and machines. NLP allows us to interact with computers using our natural language, while computer vision enables machines to perceive and understand the visual world as we do. Together, NLP and computer vision are driving innovation and shaping the future of AI. Natural language processing, or NLP, is a fascinating field of AI that focuses on enabling computers to understand and process human language. Think about it. We humans communicate effortlessly using words, sentences, and paragraphs. But for computers, language is just a complex jumble of characters. NLP aims to bridge this gap, allowing machines to comprehend and generate human-like text. One of the fundamental concepts in NLP is tokenization. Imagine breaking down a sentence into individual words or punctuation marks. That's essentially what tokenization does. It's like giving the computer the building blocks of language. Another important aspect of NLP is named entity recognition, or NER. As the name suggests, NER involves identifying and classifying named entities in text, such as people, organizations, locations, and dates. This is crucial for tasks like information extraction and question answering. Let's delve deeper into tokenization and NER. Tokenization is the process of breaking down a text into individual units called tokens. These tokens can be words, punctuation marks, or even characters, depending on the task at hand. For example, the sentence "I love NLP" would be tokenized into the following tokens. I love NLP, where NER, on the other hand, focuses on identifying and classifying named entities within text. For instance, in the sentence "Elon Musk founded Tesla in 2003, NER would identify Elon Musk as a person, Tesla as an organization, and 2003 as a date. This information can then be used for various purposes, such as creating knowledge graphs or summarizing news articles. These techniques are widely used in real-world applications. For example, search engines rely on tokenization and NER to understand your queries and return relevant results. Customer service chatbots use these techniques to understand your questions and provide appropriate responses. Sentiment analysis, also known as opinion mining, is another exciting application of NLP. It involves determining the emotional tone or sentiment expressed in a piece of text. Is the text positive, negative, or neutral? This information is incredibly valuable for businesses and organizations looking to understand customer feedback, track brand reputation, or analyze public opinion. Imagine you're a company launching a new product. Sentiment analysis can help you analyze social media posts and online reviews to gauge public opinion about your product. Are people excited about it? Are they expressing concerns or criticisms? This information can help you make informed decisions about your marketing and product development strategies. There are several approaches to sentiment analysis, ranging from simple rule-based methods to sophisticated deep learning models. Libraries like NLTK and Spacey provide tools and resources for performing sentiment analysis. For example, you could use NLTK's Sentiment Intensity Analyzer to assign sentiment scores to movie reviews or tweets. Section 5. Computer vision giving machines the gift of sight. Now, let's shift our focus to computer vision, another fascinating branch of AI that focuses on enabling computers to see and interpret images and videos. Just like NLP aims to teach computers to understand human language, computer vision aims to give machines the gift of sight. This involves developing algorithms and techniques that allow computers to extract meaningful information from visual data. Imagine showing a computer an image of a cat. How would it know what it's looking at? Computer vision tackles this challenge by using techniques like image classification and object detection. Image classification involves assigning a label or category to an entire image. For example, classifying an image as cat, dog, or bird. Object detection, on the other hand, goes a step further by not only identifying the objects present in an image, but also their locations within the image. Section 6. Image classification. Categorizing the visual world. Image classification is a fundamental task in computer vision, forming the basis for many other applications. It involves training computer models to recognize patterns and features in images, allowing them to categorize images into predefined classes. Think about how you would teach a child to distinguish between a cat and a dog. You might point out characteristic features like the shape of their ears, the length of their tails, or the way they move. Similarly, in image classification, we train computer models on vast datasets of labeled images, teaching them to recognize the distinctive features of different objects or scenes. Once trained, these models can be used to classify new unseen images. For instance, a cat versus dog classifier could be used to automatically tag photos on social media or to filter out irrelevant images from a search query. Section 7. Object detection. Locating and identifying objects in images. Object detection takes image classification a step further by not only identifying the objects present in an image, but also their locations within the image. This is crucial for applications where we need to understand the spatial relationships between objects, such as self-driving cars, robotics, and image captioning. Imagine a self-driving car navigating a busy street. It needs to not only identify that there are pedestrians, cars, and traffic lights in its surroundings, but also their precise locations to make safe driving decisions. This is where object detection comes in. Object detection algorithms typically work by analyzing different regions of an image and predicting the likelihood of an object being present in each region. If the likelihood exceeds a certain threshold, a bounding box is drawn around the object, indicating its location and class. Section 8. Python for AI, your essential toolkit. Python has emerged as the language of choice for AI and machine learning. Its simple syntax, extensive libraries, and active community make it an ideal language for developing and deploying AI applications. One of the key advantages of Python is its vast ecosystem of libraries specifically designed for AI and data science. Libraries like NumPy, Pandas, and Matplotlib provide powerful tools for data manipulation, analysis, and visualization. NumPy, short for Numerical Python, is a fundamental library for numerical computing in Python. It provides support for multidimensional arrays, matrices, and a wide range of mathematical operations. Pandas, on the other hand, offers data structures like data frames, which are essentially tables that allow you to organize and manipulate data efficiently. Section 9. NumPy and Pandas. Data manipulation for machine learning. Data manipulation is a crucial step in any machine learning project. Before we can train our models, we need to clean, transform, and prepare our data in a format that algorithms can understand. This is where NumPy and Pandas come in handy. NumPy's arrays provide an efficient way to store and manipulate numerical data. For example, you can use NumPy arrays to represent images, audio signals, or time series data. Pandas data frames, on the other hand, are ideal for working with structured data, such as CSV files or database tables. These libraries offer a wide range of functions for data manipulation, including filtering, sorting, grouping, and aggregating data. For instance, you could use Pandas to filter a data frame to select only the rows that meet certain criteria, or to group data by a specific column. Section 10. Data visualization, bringing insights to life with Matplotlib. Data visualization is an essential part of data analysis and machine learning. It allows us to explore our data, identify patterns, and communicate our findings effectively. Matplotlib is a powerful plotting library in Python that provides a wide range of charts and graphs for visualizing data. Whether you want to create simple line plots, scatter plots, or more complex visualizations like heat maps or three-dimensional plots, Matplotlib has got you covered. You can customize your plots extensively, controlling everything from the colors and markers to the axis labels and titles. Data visualization is not just about creating aesthetically pleasing charts, it's about gaining insights from your data. By visualizing your data in different ways, you can often uncover hidden patterns or trends that might not be immediately apparent from raw data. Embracing the future of AI. Natural language processing and computer vision are revolutionizing our interaction with technology. NLP enables natural communication with machines. Computer vision allows machines to interpret images, impacting areas like autonomous vehicles and medical imaging. Python is crucial for AI development with its simple syntax and extensive libraries. Libraries like NumPy and Pandas offer powerful tools for data analysis and visualization. The journey into AI is exciting and rewarding. Embrace challenges, stay curious, and explore AI's vast potential.